Hypothalamus artificial intelligence. Presence. OPTEX, optimization expert system. Making high-complexity large-scale mathematical models filling the blanks, without programming. Not programming, the dream of every programmer. Can you imagine how? OPTEX interprets the implementation of an enterprise-wide optimization system, EWOS, as a load of a relational information system converting the mathematical modeling and the software production in a filling-the-blanks process. The LAN-WAN environment makes easy the simultaneous remote work of several modelers, using the power of Internet and the database servers. For example, each modeler can work on one of the submodels that integrate the full model of a company. With the time, OPTEX has a data warehouse that contains mathematical objects that have been proven in real models, and that can be used to build new models. This works in the same way that in object programming, where to make the software, the programmer can use objects that work correctly. OPTEX generates structured programs for each model. They are error-free and easy to understand, because the descriptions that exists in the database are included to the program. The multilingual capacity of OPTEX permits description in multiple idioms, then is possible to have the same model in different languages. Maintaining the same source of information, ensuring consistency and teamwork. The traditional process of mathematical modeling implies that programmers, usually mathematical modelers or data scientists, must make great efforts to implement complex optimization models. The OPTEX mathematical modeling process is divided into 4 stages, aimed to fill the tables of the Mathematical Model Information System, MMIS, and create and store the data model of Industrial Data Information System, IDIS. The stage are 1. Design and conceptualization. Starting from the traditional formulation of an algebraic optimization model, the idea of how it should be stored in the MES must be organized. 2a. Implementation of the mathematical model in the MES. This process may be accelerated if the algebraic formulation is organized into tables in the MS Word or MS Excel documents used to write the model. 2b. Implementation of the IDIS data model to later create the relational tables that will store the industrial data. This information is stored in the MES. 3. Generation of the optimization algorithm. OPTEX automatically performs this work, integrating to source code all the elements used by the modeler, such as, for example, large-scale optimization methodologies. The whole process comes down to filling the blanks in a template, or assembling a Lego object from components built by the modeler himself. The modeler does not realize programming activities, no need to know SQL. He must be an excellent mathematical modeler that understands the concepts of high-complexity mathematical modeling. OPTEX use the same structure to storage all the mathematical components that define an enterprise-wide optimization system. Then, the mathematical modeler can use Excel or Word templates to fill the tables that integrate the MES. For implementing complex mathematical models from MS Word, the stages are: First, convert the algebraic model to a formulation in MS Word, in the form of tables. Second, convert MS Word tables into CSV files in standardized ANSI format. This may require an intermediate step that goes through MS Excel tables. Third, upload the CSV files to the OPTEX database. This process is carried out with the support of OPTEX, which automatically validates that the mathematical elements are correctly formulated. Fourth, generation of the source program of the mathematical model on the selected computational platform. The second step may be shortened, loading the information from MS Word directly to OPTEX, using the MS Windows clipboard. Next, HY presents its Research and Development plus Innovation project focused on generating a new version of OPTEX, which will be called OPTEX GPT. Through OPTEX GPT, the artificial intelligence of the hypothalamus will be your advisor for the best decision-making. The process of uploading OPTEX will be a more interactive activity through generative artificial intelligence, such as ChatGPT Omnichannel 4.0. In this way, the user will be able to communicate with the OPTEX model database, and use all the documents produced by HY for the management of the system. All through a conversation, out loud if you will, with OPTEX GPT. At the limit, if the user wishes, OPTEX GPT can perform the entire process in a single step, until the results are delivered. There is no need to store intermediate results. The basis of the OPTEX GPT conversation will be based on so-called prompting engineering, called by HY as the engineering of ideas. OPTEX GPT will be a specialized generative artificial intelligence to work in the OPTEX optimization expert system environment, which will be powered by mathematical models that exist in the current OPTEX database, and of all new models, and/or the algebraic components that will be introduced. Another source of information, commonly used to produce mathematical models, are publications, free of charge or acquired from publishers, which must be consulted by mathematical modelers, and from there, adapt the models they are going to implement. The idea is that OPTEX GPT can help in this process of normalization of unstructured information sources to information structures in MEs. From the correct configuration of the MEs, the modeler will be able to configure the required algorithms, link them together, and generate the computational code of their choice. Finally, she will be ready to run the multi-problem models. An evolved OPTEX GPT could help experts in field problems, but not experts in mathematical modeling, to generate advanced, ready-to-run mathematical models. The data source for building a model can be the description of the real model, and/or the algebraic formulation, and/or pre-existing models in the OPTEX database. Another of the functions of OPTEX GPT will be aimed at supporting users in specific applications, to accompany them in the process of elaboration, or selection, of mathematical models, the loading of industrial databases, and the interpretation of the results. The main product is the management of IDIS, Industrial Data Information System. This work will be advised by OPTEX GPT, based on the data model of the IDIS database. This includes the verification of the validity of the database, considering the metadata of each of the fields of the tables. As an advisor, OPTEX GPT will have access to a database of documents, some generic and some specific, to facilitate the understanding of the company-wide optimization system by the user group. Mathematical programming, better known as optimization, has changed because of Industry 4.0. In the past, mathematical modelers were oriented to implement programs, built from the algebraic equations of mathematical problems using a computer language. This approach is not feasible for building high-dimensional business models, not because of the mathematical complexity, but because of the large dimensionality involved in problems with millions, or trillions of variables and constraints. The practices of the future, as demonstrated by an artificial intelligence such as GPT, are mega models that replace a large part of human work. Mathematical Programming 4.0 does not escape this trend. A mathematical model can be conceived as the union of mathematical components harmoniously integrated. The expert OPTEX system impacts the way of making models, since the expert database stores all the mathematical components of the models, so that the programming of a supermodel is based on connecting problems together, using the memory of everything that has been done in the past. A mathematical problem can be conceived as the union of harmonically integrated algebraic components. These components are stored in a relational information system, which makes their handling modular, by using structured query language, SQL, to manipulate mathematical objects. The expert OPTEX system impacts the way models are made, since the expert database stores all the mathematical components of the models, so the programming of a supermodel is based on connecting problems with each other, using the modeler's memory of everything that has been done in the past. This conceptualization is independent of optimization technologies, which allows to separate the formulation of the mathematical models from their implementation, using a specific optimization technology. This allows you to make mega models like a Lego game. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.